Problem number 1.328. That water flows out of a big tank along a tube bent at right angle like shown in this figure. The inside radius of tube R is equals to 0.50 centimeters. So we will write at 10 to power minus 2 meters. Okay, and the length of horizontal section, which is shown here, this L, is equals to 22 centimeters. So it is 22 power 10 to power minus 2 meters. Okay, the water flow rate, that is Q, is given as 0.50 liter per second. Okay, now next is find the moment of reaction force flowing water acting on the tube wall at this point O. Okay, so here we need to find out the moment of reaction force working on the tube walls about this point. Okay, so moment of force means multiplication of length and force working on it. Okay, so let's see. When fluid will come out from this point, okay, so there will be a thrust in upward direction that would act at this point, right? According to Newton's law of action and reaction, if liquid is coming out with certain thrust because there is change in momentum, then according to rate of change of momentum, there will be a force F which would act at this point, at this corner. And the length of this force, line of action of this force, is L distance away from point O. So if we'll calculate moment about point O, it would be F multiplied by L. So first of all, we need to find out this force. Okay. So as we are aware that force is equals to rate of change of momentum, d over dt into m into v. Okay, mass into velocity. As it is coming out, so we can take negative sign. Now, if this we consider a small section of this moving liquid as distance x, this cross-sectional area as A. So we can change this mass in terms of density, that is rho A into dx into V. Okay, so from here we will take this term inside as the rest of the values are constant. Then we can write force is equals to rho into A dx over dt into V. And this dx over dt shows the velocity of liquid that is coming out. So F is equals to rho A V into V, this is V square. So this is the magnitude of the force acting on this point. Now in the question it is saying the outflow rate Q is equals to 0.5 liter per second, or we can take it in centimeter cube. Okay. So this Q would be equals to A into V, where A is the area of this opening and V is the velocity. So we can calculate this velocity in terms of area, that is Q upon A. Now we will substitute in this equation, then a thrust which is working at this point is equals to rho A Q over A whole square. So from here we'll get force rho into A rho A would be get cancelled. So it is Q square upon A square. Okay. So now we have the force and the length is known. So we can calculate this moment of force T naught. So T naught would be equals to rho Q square L upon A. As area is not known but radius is given. So we can write that T naught is equals to rho Q square A upon pi R square. Now all numeric values are known, so we can substitute here that density of liquid is 1000, Q is given 0.50 whole square. This length is given, let's keep them in centimeter as we are taking this liter as centimeter cube, upon pi into 0.5 whole square. This is the radius 0.50. So if we'll solve them, then the solution would be 0.70 Newton per meter. Okay, this is the moment of force working on the walls about point O.